Hello, my wonderful viewers. Welcome to OCT Part 15. Today, we're looking at 12 principles of green chemistry. You wonder why green chemistry? Chemistry has profoundly transformed modern life, from medicines we take and materials around us to the energy we use, even agriculture and food preservation. It underpins the fertilizers that increase crop yields, the materials that shape modern infrastructure, and the technologies that power our everyday lives. However, many traditional chemical processes have also contributed to the pollution of water, pollution of the environment, and everything around us. That is why we turn to green chemistry, which has a different and more sustainable approach. Instead of cleaning up pollution after it occurs, green chemistry focuses on preventing pollution at the source by designing safer chemicals and more sustainable processes from the start. In this video, we'll take a clear and simple look at the 12 principles of green chemistry, which form the foundation of sustainable chemical innovation. The first question is, what is green chemistry? Green chemistry is the design of chemical products and processes that minimize or completely eliminate the use and generation of hazardous substances, promoting sustainability and environmental protection. It considers the entire life cycle of a chemical from raw materials to synthesis, its use, and its final disposal. The goal of green chemistry is to make chemistry smarter, safer, and more responsible. What are these principles? Green chemistry is guided by 12 core principles that serve as a framework for designing safer and more sustainable chemical solutions. These principles are: 1. Waste prevention. That's the first one. Very simple. It is better to prevent waste than to treat or clean it up after it is formed, because avoiding waste saves resources, reduces costs, and protects the environment. Principle 2. Maximize atom economy. Chemical reactions should be designed to ensure that most of the starting materials end up in the final product. High atom economy means less waste and higher efficiency. Principle 3. Less hazardous synthesis. Synthetic methods should use and generate substances with little or no toxicity to human health and the environment. In green chemistry, safety is designed into the process and not added later. Principle 4. Designing safer chemicals. Chemical products should perform their intended function while being as non-toxic as possible. Effectiveness and safety must go hand in hand, must go together. Principle 5. Safer solvents and auxiliaries. You have to avoid harmful solvents and auxiliary substances whenever possible. When they are needed, the safest available option should be used. Many traditional solvents are toxic, but greener alternatives make a big difference. Principle 6. Energy efficiency. Energy requirements should be minimized. We are to conduct reactions under ambient conditions to save energy and impact on the environment. Principle 7. Renewable feedstocks. Whenever technically and economically possible, raw materials should come from renewable sources rather than fossil fuels. This supports long-term sustainability. Principle 8. Reduce derivatives. Unnecessary steps such as protecting groups or temporary modification should be avoided. Fewer steps mean less waste, fewer reagents, and lower energy use. Principle 9. Catalysis. Use catalysts instead of stoichiometric reagents to improve resource efficiency. As you know, catalysts enable reactions to proceed efficiently while being reused, thereby reducing waste and resource consumption. Principle 10. Design for degradation. Chemical products should be designed so that they break down into harmless substances after use. This prevents long-term environmental accumulation. Principle 11. Real-time analysis. Analytical methods should allow real-time monitoring and control of chemical processes. This helps detect and prevent hazardous substances before they form. Lastly, principle number 12. Inherently safer chemistry. Chemical processes should minimize the potential for accidents, such as explosions, fires, and release of toxic substances. Safety should be built into the chemistry itself. Let's run through again. What have we learned in summary in these 12 principles? They are to guide chemists towards cleaner production, reduced waste, lower energy use, and safer chemicals and processes. These are applied across pharmaceuticals, material science, energy, agriculture, and environmental protection. Green chemistry supports sustainable development without sacrificing innovation. It allows society to meet today's needs while protecting future generations. This is not just good science, it is responsible science. Green chemistry shows us that chemistry can be both powerful and sustainable. If you find this explanation helpful, like the video, hit the notification button, and subscribe to the channel for more exciting videos.